Garlic is not polite food. It does not ask permission. It announces itself before you even see it. Its smell travels faster than its appearance, and once it is present, it dominates memory. Garlic is one of the few plants whose identity is inseparable from its aroma. Botanically, garlic is allium sativum, a member of the Amaryllidaceae family. This places it alongside onions, leeks, shallots, and chives. Allium plants share one defining trait: sulfur-based chemistry. This chemistry is responsible for both flavor and biological activity. Garlic is a bulb-forming perennial, though it is cultivated as an annual. The bulb is composed of individual cloves, each wrapped in a thin papery skin. Each clove is a complete genetic copy of the parent plant. Garlic does not reproduce through seeds in most cultivated forms. It is cloned generation after generation. This matters because garlic is propagated vegetatively. Humans directly shaped its evolution. The garlic we eat today exists almost entirely because people selected cloves with stronger flavor, larger size, and greater resilience. Garlic's origins trace back to Central Asia, likely in regions covering modern-day Kazakhstan, Uzbekistan, and surrounding areas. From there, it spread east into China and India and west into the Middle East, Egypt, and Europe. Garlic traveled with armies, traders, and migrants. It was never luxury food. It was survival food. Ancient Egyptian records show garlic being fed to pyramid workers. The belief was simple: garlic increased strength and endurance. Whether symbolic or physiological, garlic became associated with labor, power, and protection. In ancient Greece, athletes consumed garlic before competitions. Roman soldiers ate it for courage. Across cultures, garlic was seen as fortifying. This reputation did not arise randomly. The defining chemical reaction in garlic occurs when a clove is cut or crushed. Inside intact garlic cells are two separate components, allium and the enzyme alliinase. When the cell walls break, these combine to form allicin. Allicin is the source of garlic's sharp, pungent smell. It is also biologically active. Allicin is unstable. It breaks down into other sulfur compounds such as diallyl sulfide, diallyl disulfide, and ajoene. These compounds are responsible for garlic's lingering aroma and many of its physiological effects. This chemistry explains why cooked garlic smells different from raw garlic. Heat alters sulfur compounds. Raw garlic is sharp and aggressive. Cooked garlic becomes sweet, nutty, and mellow. Transformation defines garlic's culinary role. Nutritionally, garlic is not consumed in large quantities, but its impact is disproportionate. It contains vitamin C, vitamin B6, manganese, selenium, and trace minerals. More importantly, it provides organosulfur compounds studied for cardiovascular and antimicrobial effects. Garlic has been used medicinally across civilizations. Traditional systems used garlic for infections, digestion, parasites, and circulation. Modern research continues to investigate these uses. Garlic's antimicrobial reputation is rooted in real chemical activity. Sulfur compounds can inhibit certain bacteria and fungi. This likely contributed to garlic's historical role in food preservation and safety. Smell was protection. Culturally, garlic occupies a strange position. It is both celebrated and stigmatized. In some societies, garlic breath is associated with poverty or lack of refinement. In others, it signals authenticity and flavor. This divide shaped cuisine. French, Italian, Chinese, Korean, Indian, and Middle Eastern cuisines all rely heavily on garlic. In contrast, some Northern European traditions historically minimized it. Yet globalization erased many of these boundaries. From a cooking perspective, garlic is foundational. It is rarely the star, yet almost everything depends on it. It builds flavor bases, supports fats, and bridges ingredients. Garlic reacts with oil differently than most vegetables. When gently heated, it infuses fat. When overheated, it turns bitter. Timing matters. This sensitivity makes garlic a test of technique. Garlic also exists in many processed forms: dried, powdered, granulated, fermented, black garlic. Each form alters chemistry and flavor. Black garlic deserves special mention. It is not a separate species. It is fresh garlic aged under controlled heat and humidity. This process triggers Maillard reactions, turning cloves black, soft, and sweet. The pungency disappears. Umami replaces aggression. This shows garlic's range. Agriculturally, garlic prefers cool seasons and well-drained soil. It requires months to mature. Hardneck and softneck varieties differ in scape production and storage ability. These distinctions affect flavor intensity. Garlic scapes, the flowering stems of hardneck varieties, are also edible. They provide a milder garlic flavor and represent efficient use of the plant. Nothing is wasted. From a sensory standpoint, garlic stimulates more than taste. Its aroma interacts with memory and emotion. Many people associate garlic with home cooking, family meals, and cultural identity. This emotional link is powerful. Garlic also influences the body beyond digestion. Sulfur compounds are excreted through breath and skin. This creates garlic odor long after consumption. This is not a flaw. It is a biological signature. Garlic does not hide. In modern nutrition debates, garlic appears frequently as a superfood. This framing oversimplifies it. Garlic is not magic. It is functional, historically tested, and chemically active. Its value lies in consistency, not hype. Garlic survived every dietary shift because it adapts. Raw, cooked, fermented, medicinal, symbolic. Few plants can claim that range. In the end, garlic is not optional in human food history. Remove it, and entire cuisines collapse. Flavor structures break. Cultural memory fades. Garlic is not background noise. It is infrastructure. And once you understand garlic, you understand why humans never let it go.